In this training, we will be discussing arc flash awareness, more specifically what an arc flash is, what it can do to us, and how we can protect from it. There's two words I want you to think about while you're watching this video, and that is situational awareness and complacency. And I'll talk further about how those relate to protecting against arc flash. So basically, an arc flash is a phenomenon where it's a flashover of electric current. It leaves its intended path, typically a conductor, and travels through the air, which is why we're able to see it, and either goes to another conductor or it finds its path to ground, which is what electricity is always trying to do. It's important to note that the higher the voltage and the shorter distance to the main power supply, the greater an arc flash or blast will be. So when we're going to talk about arc blast in a minute, but being able to understand how intense the voltage is and how short the distance is very important when you're dealing with any electrical current. So there are things that can actually help aid in an arc flash, and that's dust. So dust is typically produced like by corrosion of any type of conductor in an electrical circuit. If that builds up, it will help promote an arc flash. Dropping tools, it's always important when you're wearing dielectric protection such as gloves that you maintain a good grip on your tools, that we're using the correct insulated tools, and that we're keeping our eyes on task, and maintaining good situational awareness. Also, accidental touching, this is why we wear dielectric protection, for the chance that, you may come in contact with a circuit, an energized circuit of any kind. So it's important that you maintain good situational awareness. You don't get complacent so that you're not touching circuits and completing the circuit. Condensation, any type of moisture buildup will also help promote an arc flash. It's also important to know that environmental conditions such as high humidity will promote arc flash as well. Any type of material failure, maybe from a faulty insulation or be the natural degradation of that material, will help aid in arc flash being present. Injuries from an electrical arc flash can be very severe. In fact, they could result in a fatality. So it's important that we're looking at the factors that affect the severity of how bad an injury can actually be from an arc flash. So when we're trying to protect against it, we need to establish what the proximity the worker is going to be from the actual arc flash hazard that potentially might be present. So this is why we're going to talk about boundary distances away from any type of potential arc flash or energized circuits. Then we're going to look at temperature. So this will be dependent on the voltage that's actually running through and how severe the arc flash will be, but also the temperature. And we're looking at potential burns and how to protect from burns, and also the right PPE that would also prevent burns. And then also we're going to look at the time for the circuit to break. So there are protections that are in place, safety protections, such as circuit breakers, fuses, stuff that's going to basically cut off the circuit in the event that there is some type of overload, basically, from what an arc flash would produce. So when we're looking at electrical arc flashes and what they can actually create and what other hazards they can introduce into a situation, it's important to understand them so we can protect against them. So burns, a lot of people underestimate burns. If you get burns over a certain percentage of your body, it can easily result in your death. So it's important that we manage burns and that we make sure that we try to do everything we can to prevent against a human being actually burning. We'll talk about later in the training about how we're always trying to manage burns to either be non-existent or to be at no more than a second-degree curable burn, something that you can recover from. Next is fire. So arc flashes can help ignite a fire. So if you have any kind of ignition source that's around you when an arc flash is present, you will be introducing a fire hazard at that point, just making the situation that much worse. Next is flying objects such as molten metal. These will be produced by not so much the arc flash, but the arc blast, so the actual circuit blowing up. Blast pressures can be upwards of 2,000 pounds per square feet. Many technicians have reported that it feels like being shot by a shotgun shell. Next is the sound blast. Just like when a shotgun is fired, it creates a loud noise. You're going to get the same thing from a arc flash and or blast. And when you're talking about 140 decibels or above, that can easily blow out your eardrum. That's why hearing protection is very important when you're working within the arc flash boundary. Next is heat. We've talked about heat, which will cause burns and fire. You're looking at upwards of 35,000 degrees Fahrenheit, depending on voltage, of course. But that is hotter than the surface of the sun. So that is why it's very important to manage and also maintain situational awareness so that we don't even encounter an arc flash in the first place. Now we're going to talk about approach boundaries, and these are created and updated by the National Fire Protection Association, commonly known as NFPA. So when we're looking at specific electrical standards, we're looking at NFPA 70E. As far as OSHA is concerned, OSHA just spells out and tells the employer that they have to protect their employee, but they don't actually go into the real specifics of how to do that. So that's why NFPA 70E is referenced when an employer is looking how to protect their employees. So they develop specific approach boundaries that are designed to protect employees while working on or near energized equipment based on a worker's distance away from a live part. The distances will increase and decrease dependent on what qualifications you have, and also how large the source or the voltage is that you're going to be working around. So when we're determining approach boundaries, we need to look at the actual circuit, or where the source of power is, and imagine rings or different stages around that in a circular fashion. So the very outer band, or the outer ring, we're going to call the flash protection boundary. And this is where you can be exposed to a curable second-degree burn, but we still have to have PPE required to prevent the incurable burns. That's why anyone within that flash protection boundary will need to have the basic PPE ensemble. Next is the limited approach. So this is where the shock hazard exists. This is where the actual arc can extend out and get in this limited approach. This is the closest that an unqualified person, so an unqualified electrical worker, can approach. Next is the restricted approach. So this is a greater risk of electrical shock. And this is the closest that a qualified person can go without wearing the proper PPE and have the proper insulated tools present. And then the final area right in the center, right next to the circuit, the prohibited approach. This is considered to be the same as making contact with the live part, even if you're 10 inches away, depending on voltage, of course. And this is where you're basically needing to have the correct dielectric protection and to have the proper PPE to actually work on the circuit. So this graphic is a great illustration of what approach boundaries look like. And when we're looking at approach boundaries, situational awareness is vitally important to not only protect any of the other workers on the job site, but to protect yourself and any visitors or anyone from the public that may encroach on the approach boundaries. So being aware at all times where everyone is and making sure that they don't put themselves in danger. So looking at the very center of the rings there is the energized equipment. And then the next area is the restricted approach boundary. So this is where the qualified electrical worker will be working on the circuits or work within close range of the circuits. And thus will have to have all the dielectric protection and the insulated tools as well. So the limited approach boundary is the next ring, and that is where the unqualified worker will be stopping. So again, this is all dependent on voltage, but it is important that they're also wearing the appropriate PPE so they do not get an electrical shock or they not get any type of burns. And finally, the outer ring is the flash protection boundary. So again, we're still at risk for getting any type of second-degree curable burns, and then we have our PPE to protect against any additional uncurable burns. So when we're looking at where the different boundaries will start in relation to the energized electrical circuits, we're going to first try to figure out what voltage that we're dealing with. So in the example that I'm going to give you, the greatest voltage that we're going to be exposed to is 13.2 kilovolts. So we're going to look at column 1 and go down to where that would fall between, and it'll fall between 751 volts to 15 kilovolts. So if we go over and we look at the limited approach boundary, it's important to understand that this is where the potential for an electrical shock does exist. And this is where the unqualified worker electrical worker will have to stop. So there's two different distances that we're looking at here, but I don't want anyone to get confused when looking at this table. At CALTS, to make it universal and to make it easily understood, no one should be within a 10-foot distance from any electrical source without having the proper PPE on. So at no point should anyone be anywhere within the limited approach boundary, restricted approach boundary, or prohibited approach boundary, or within 10 feet of any energized circuit. So with that, without said, let's move on. So any type of exposed primary conductor that might be able to be movable is going to be moved by the splicer. So it's not anything that we're going to be doing, but it's important to understand that once that conductor is able to be moved, it's going to increase that distance. Next is the fixed circuit part. So whether it's live front, dead front, it doesn't matter. Dead front, it may be insulated, it may be protected. We're still going to treat it as exposed, so that there's no question. Again, we want to have a universal knowledge so that we're ensuring that no one puts themselves at risk. So that'll lower that boundary to 5 feet. Next, we're looking at the restricted approach boundary. This is where there's an increased risk of shock, electrical shock, and again, this is where a PPE requirement is very important. So at this distance, they have it labeled at 2 feet 2 inches. And then finally, the prohibited approach boundary. So this is, you should have in your mind that if you're within this area, you're basically working on it. Even though it says, 7 inches from the exposed electrical circuitry, you are considered to be working on it. So that's when you need to make sure that you only have your insulated tools around and that you have all your dielectric protection and your FR clothing on. So when we're looking at the protective measures that we can take to reduce the risk and reduce the potential for any type of injury to occur, we need to understand and look at the hierarchy of controls. So when you're looking at the hierarchy controls, the best thing that we can do to take a hazard out is just to completely eliminate it. So when we're talking about energized electrical circuits, you can eliminate the hazard by completely de-energizing it before you start work. So you do this by identifying where's the power coming from. So you want to identify all power sources. There may not just be one, there may be multiple. So it's important to identify that before you're trying to de-energize. Next, when you're going to disconnect the power, you need to ensure that the load has been taken off. So you never want to disconnect power when there is any type of load on the circuit. Next, you want, if you're able to do this isn't very probable in the line of work that we do, but if you're able to visually verify that something has been disconnected or a circuit has been opened, that is a great means and another verification method. And finally, testing for voltage. So to completely ensure that a circuit has been de-energized, we're going to grab our voltmeter and we're going to test and make sure that we're reading 0 before we're actually starting to work on the actual circuits. Next is guarding procedures. So, say if you're, if a PED's right by a transformer or there's any exposed electrical circuits and you're working on something else, just putting the cover on the PED or closing the door of the transformer. These are different guarding procedures that you can do to reduce the risk when you're actually working on any exposed electrical circuitry. And then finally, setting up barricades, right? Setting up those visual indicators to let the public know, to let other your crew members know where they can and can't go. And those visual means can really help jog someone's memory that, hey, I can't go here. So again, situational awareness is very, very important here, and setting up those visual indicators that no one unintentionally walks within an area where they put themselves at risk. So there are times where you may have to work on energized electrical circuits or quote unquote hot energized electrical circuits. So it's important that we have safety related work practices, that we provide you with the right PPE, that you wear the right PPE. If you have questions about your PPE, it's important that you get those answers. And this is why we train on this stuff, so that when you are having to work on energized electrical circuits, you reduce your risk because you have the knowledge to do so. Next is using the insulated tools. We have written safety programs, so you can always refer to any type of job units, or you can refer to our safety manual if you need help with anything. And then also, everyone may wonder where the job briefings come from. It's not an Edison requirement. It's required by law for you to have a job brief present. So it's just basically having that conversation, understanding what voltage that you're going to be working on. Make sure that you have all your PPE before you get into the job. You never want to get into something and realize that, hey, I don't have what I need. This should all be established and thought out during the job brief, so that you're protected to the max when you're going to work on any exposed electrical circuitry. So the PPE that we required include the following. So first, safety glasses. Again, these should be worn on the job site at all time, but they do aid in protection against any type of arc flash protection. Next is the voltage rated gloves. So again, it's important to identify what voltage that we're working around. I'm going to get into a little bit more of what specific requirements are going to be for what in the next couple slides. But just know that you have to have the right voltage rated gloves for whatever voltage that you're working on. Next is the fire resistant or flame retardant clothes coveralls that we issue out. So I'm going to go over a little bit more of the specifics on what to look out for and to make sure that they are rated for what they need to be before you're starting any of your work. Next is your arc related face shield. So when we're installing meters, this is where we're going to need the arc rated face shields. And then finally, as I talked about before, the shotgun going off, an arc flash or blast is going to create a significant noise that could hamper your hearing, or it could disable your hearing by blowing out your eardrums. So this is why we use hearing protection. So OSHA has strict guidelines in their standards for labeling instructions for manufacturers who manufacture FR clothing. So it's important that that you don't just throw on a pair of coveralls thinking, oh, they're FR, they're good. No, they have to meet a specific requirement. So make sure that you understand the voltage that you're working with and that you have the right coveralls for that. I will tell you that the coveralls that we issue are 8 calories, and they are more than enough for the maximum 13.2 kilovolts that we are going to be working around. So to basically break down the tag that the specific requirements that the manufacturer has to have, you got to have the tracking code, statement that the garment meets the requirements, manufacturer's name, size information, care instructions, so on how to take care of it, how to maintain it, how to wash it, the fiber content, and also the arc rating and what it's good for. So when we're looking at the CALT's PPE requirements when working around exposed electrical circuits within the arc flash boundary, we need to, at all times within the 10 feet, need to be wearing the hard hat, the leather work boots, the FR coveralls, and the glasses. And now with the COVID pandemic and the requirement for wearing a surgical mask at all times, you will need to take off your other surgical mask, the standard surgical mask, and you'll need to replace it within the 10 feet with the arc rated surgical mask. So if you are able to be working on exposed circuits or able to be within that arc flash boundary, you need to be provided a surgical mask that is FR rated. So when we're opening up transformers, we've got to have a little extra protection. This is why we have the class 2 gloves that are rated up to 15,000 volts. So again, this is to ensure that the transformer is not energized and can give you an electrical shock because maybe one of the cables is exposed inside because it was chafed. So once you've opened the transformer, you confirm that there is no exposed primary present. You're able to take those class 2 gloves off and put on your class 0 gloves to make any secondary connections. Next, for installing meters, you have to have 2 additional pieces of PPE. You have to have your face shield, when you're installing a meter, and you actually have to have your hearing protection. So again, the top area is required within the 10 feet at any time, and then you have your specifics for installing meters and then for opening transformers. So I'm going to close with the HRC chart, or the arc flash PPE requirement chart. This is directly out of NFPA 70E. So, when we're installing meters, we're going to fall under PPE category 1. So all the different categories are determined by the incident energy. And so the incident energy and protecting against it is where you're getting your calories per centimeter square. So if you look at category 1, this is going to be up to 4 calories per centimeter square. Category 2 is up to 8 calories per centimeter squared, and so on. 3, 25, 4, and 40 calories per centimeter square. So again, for setting meters, you're going to fall into category 1. You're actually overprotected with the coveralls that we provide because they are rated up to 8 calories. But then you have your face shield, you'll have your gloves, and then you'll have your leather work boots. So category 2, this is typically where you're going to fall under if you're breaking into a live duck run, if you're on a duck run crew, where you're chipping concrete. So again, we'll know the voltages ahead of time, and we'll have a safety stand on before any of that work commences to make sure that you have all the protection that you need. But it's always important to ask that question, like, hey, do I have everything I need to wear to perform this work? So the only really addition that you'll have for category 2 is the baklava that will be underneath your face shield to protect your skin of your neck and then your face. So again, this will be thoroughly went over before any of that work commences. So in closing, if you have any questions relating to this training or anything safety related, please get your questions answered. It's important that you never go into a situation where you're not sure if you're doing the right thing or if you have the correct PPE to perform the task. So always get your questions answered. Also during the pre-job briefs, that's a great time to get your questions answered, so make sure you do so then. So with that said, I appreciate you attending the training, and please let your foreman know that you have attended the training for documentation purposes. Thanks.